Okay, so here's your review video for week 15-16 review. I'm just going to go one problem at a time. All right, this first problem is something you're going to have to either use substitution or elimination because they're both in standard form. We're going to use elimination. That means we need perfect opposites. Right now, my y's are the same value, and I need them to be opposite. So I'm going to multiply my bottom equation by -1. All right, that's going to give me 2x plus y equals 24, and negative 3x minus y equals negative 16. Remember, with elimination, we got to cancel, add everything that's left. So that's going to give me negative 1x equals 8. I'm going to solve for x. So x is going to be negative 8. And then I also need a y value. So to get the y value, we're going to plug back into our original equation. So I'm going to do 2 times negative 8 plus y equals 24. I can multiply my 2 and negative 8 to get negative 16. And then to get y by itself, I have to use opposites to move the 16 across. So y is going to equal 40. So my final answer is going to be written as an ordered pair, negative 8, comma 40. All right, question 2. This is a word problem. Before I can answer the question, I need to write an equation. So if I have money, this problem secretly has some more money information. They're telling me that I have $1 bills and $5 bills. So if I think about my money parts here, I've got 1x plus 5y equals 90. All of those have to do with money. And then there are 42 bills total. So to write that one, that's just x plus y equals 42. All right, they're going to ask me how many $1 bills and how many $5 bills are in the jar. So that means I need to solve. This right here is elimination because they're both in standard form. So I'm going to fix this. The easiest fix is probably to multiply the bottom by -1. So if I do that, I am going to get 1x plus 5y equals 90. The top's going to stay the same. Negative 1x minus y equals negative 42. All right, cancel my opposites, my x that are opposites, and then add everything else. So that's 4y equals 48. Divide. All right, and that's going to give me y is 12. And then I also need to find x, and to do that, I'm going to plug back in. So to find my x value, I'm going to plug back in 1x plus 5 times 12 equals 90. I can multiply 5 and 12 to get 60. Subtract 60 from both sides. So that means x is going to equal 30. And when I go to answer my question, how many $1 bills and how many $5 bills, there are, so $1 bills, there are 30 of those, and $5 bills, there are 12 of those. All right, so that's going to be your final answer. All right, question 3 is asking me which of these points, or to evaluate if each point is or is not a solution. Well, to be able to do that, I actually have to look at the this problem on a graph. So I'm going to graph my first equation. I'm going to start at 4, and the slope is down 3 over 1. Remember, I want to make that go as many times in my graph as I can. Thinking about this symbol right here, that is going to be a dashed line, and I'm going to be shading below. So I'm going to go ahead and shade this one below. All right, then my next equation is going to be right here. I'm going to start at -1. This time I'm going to go up 2 over 1. Remember, make that go as many times in your graph as you possibly can. All right, that time, if I look at my symbol, it should be solid. So I'm going to make that a solid line, and I want to shade above. So I'm going to go ahead and shade this one above. And remember, I'm looking for where they overlap for the solution. So in general, my solution area, All right, my solution area is in this corner over here. I'll just go ahead and say things that are on the solid line are solutions. If something is on the dashed line, it is not a solution. So just keep that in mind. So if I go ahead and plot my points, -2, 3. Oh, I'm sorry, -2, -3. All right, that's down here. That's A. And that one is in the double shaded area, so yes, it's a solution. 0, 0, B, same thing. 1, 1, now 1, 1 is going to be no, because it has to be in both sections, and it is in the green section because that's solid, but it's not on the red because that's a dashed line. So that's why that one's going to be no. And then +2, 3, that's up here. That, again, that's only true for the green, not for the red line. So that one is also going to be no. Okay, this last problem on this little corner is asking me to write a system of inequalities. So I want to write equations that look like y equals mx plus b, but instead of equals, right here, we're going to have an inequality symbol. So that means I'm going to have like greater than or equal to, less than or equal to. So we've got to first, I'll start with this line. I'm going to say I'm starting at 0. My slope is up 1 over 3. So that's going to be y, I'm going to leave a space, 1 over 3x plus 0. And think, this is solid, and if you look at this line, they're shading below. So that's going to be less than or equal to. On my other line, so now I'm going to look at the other one, I'm starting at 2, up 2 over 1. So that's going to be y, I'm going to leave a space, 2 over 1x plus 2. And then think, this one is solid, but this time I'm shading above. So now I'm going to be greater than or equal to. All right, so there is your answer for that. When it says to write a system, you should be writing 2. So system is going to give you 2, and inequalities means you're going to have your less than or greater than symbols. Okay, question 5 here. We kind of touched on this just a little bit. We didn't spend a ton of time here. Last week we talked about how if two lines have the same slope, they're going to be parallel. So notice that A, B, and C here all have the same slope. So I want to show you kind of a little trick, I guess, something to think about. I'll actually sketch this out to the side. So if we've got parallel lines, we have a few different options. We could shade them both the same direction, so those could both be down. And since these have an overlapping area, this would be an example of yes, because you have something overlapping. Or we could have two parallel lines that shade opposite directions, so like one of them shades up and the other one shades down. That's also going to be yes, because we have an overlapping section. The last option, though, is that we could have two parallel lines where the top shades up and the bottom one shades down, and since there's no overlapping area, this one would have no solution. All right, so let's use that same mentality to think about question 5. So question 5, my top equation is going to start at 4. So I'm just going to guess. It's starting at 4 and it's shading down. Then my next equation is going to have a parallel line that starts at 6 but shades up. Well, neither of those are going to overlap, so that's going to be an example of no. All right, let's look at B. The top equation is going to start at -4, and greater than means I'm going to shade up. I'm going to have a parallel line that starts at +1 and is going to shade down. Those are going to shade towards each other, so that one's going to be yes, because it's going to have an overlapping section. All right, C, I have my top equation. I'm starting at 1, and greater than means I'm going to shade up. The other one is going to be, there's nothing out here, so I'm starting at 0, and this tells me I'm going to be shading down. Again, there's no overlapping section, so that one's no. The last one, notice that these are not going to be parallel. So I mean, we can graph those and see what they look like, but it doesn't even matter. If they're not parallel, then something is going to have to overlap. So this one is going to be a yes, and I know that even without having to graph it. All right, question 6 is asking which is not a solution. So I'm just going to go through and graph and show you -1, 4. All right, there's A. B is at 0, 4, which means I don't go over any, and I go up 4. That's B. C is at 1, 4. And D is at 2, 8. Now, D is kind of up here off the graph. We can assume that D, though, is probably, it looks like it's going to fall in this double shaded area at the top here. It looks like it's going to fall somewhere in here. So the question is, between A, B, C, and D, which one is not a solution? And C, right here, is my non-solution because it's on the dashed line. So C is not a solution because it's on the dashed line. All right, question 7 here. Again, word problem. To be able to solve, I need to write my equation first. So when I'm highlighting, I notice that I'm not comparing two things. This is all one big problem. So I notice that all of my money is going to go together. So I'm going to highlight all of my money pieces. And then I'm looking, remember I want to look and see, do we have any rates here? So in my money, it says each chair and each desk. Those are two different rates. Okay, so one of my equations is going to be 125x plus 515y equals 4,870. Oh. All right, and then my other, it says there's a total of 14 chairs and desks. So that just means x plus y equals 14. All right, now we're going to have to solve, and this is elimination. So again, this is the third time I'm doing this, right? We need to multiply the bottom equation, and I'm going to choose to multiply my bottom equation down here by -125. I'm just trying to eliminate the x's here. All right, so that's going to give me 125x plus 515y equals 4,870. The tops staying the same. The bottom one is going to become -125x minus 125y equals -1750. All right, I'm going to cancel and add. And I'm going to get 390y is equal to 3,120. And if I divide to solve for y, I'm going to get y is equal to 8. All right, and then I need to plug back in to get my second value. So I'm going to use an original equation. The easiest one to use is actually the bottom one, x plus y equals 14. So x plus 8 is 14. So if I subtract 8, y is going to be 6. And then just go back and read how many chairs and how many desks. Well, x was my chairs and y was my desks. So that means I have, oh, I miswrote that down there. That means I have 6 chairs and 8 desks. Okay, 8 is a question that I might solve by graphing. So this first problem, to graph, we can do that using cover-up method. All right, so if I do that, I've got two equations. I have 6x equals 30, which means x is going to be 5. So I can make a point at 5. Then I also have 3y equals 30, so y is going to be 10. All right, that's just our basic cover-up method, so we can connect those. Ooh. All right, and then my second one, that looks a little strange, so I'm actually going to fix that before I graph it. And to do that, I'm going to multiply. So the y minus 4 is going to stay the same. I'm going to distribute this -2. So -2x plus 6. And then I'm going to move the 4 over, so that's going to be y equals -2x plus 10. So start at 10, and then -2 over 1, -2 over 1, -2 over 1. So you may start to notice this line is directly on top of the other one. So that is going to give us, if you remember, infinitely many solutions. All right, infinitely many solutions. Okay, this last problem, because these are y equals to solve, you're going to have to use substitution. And on this one, I actually kind of made an error, but I'll go ahead and solve it anyway, just so you can check what you have. 6x plus 25 equals 4x plus 30. All right, so we're going to subtract 4x from both sides to get my x's together. And then I'm going to subtract 25. So I've got 2x equals 5. Divide by 2, that's going to give me x is 2.5. So the question is, for how many hours do they charge the same amount? And this answer would tell us it's at 2.5 hours that they would charge the same amount. All right, question 10 up here. Again, we're going to have to graph to solve. So I start at -4, down 1 over 2. Remember to make the pattern, I'm just going to say it over and over again, make the pattern go all the way through the graph. This symbol is going to tell me solid and above. So I'm going to connect this with a solid line. And my shading is going to be above. All right, and now I'm going to do my second line. Start at 1. My slope is up 1 over 1. I'm going to make it go, all right, I'm going to go back on my word, make it go all the way through the graph, but I'm going to be lazy for a second. All right, that symbol means solid. And this time we're going to go below. So we're going to shade below. And when we look at where they're overlapping, the next part says to give two that are solutions and two that are not solutions. So the solution area is this kind of whole section over here where they're overlapping. So you just want to name any two ordered pairs in that section. And then non-solutions are everything else. So for example, like -6 and 1, this would be a non-solution because it's not in the double shaded area. 0, 0 would be a solution because it is in the shaded area. So make sure you have 2 points named for part B. All right, last problem here. If we read, a college student is deciding between 2 different jobs. So we're going to go ahead and say one job pays $25 an hour, and the internship pays $12 an hour, and he wants to earn at least $250 a week. All right, so if I want to write the equation for that, I've got 2 rates, so that's standard form, so 25x plus 12y at least means 250 is the least amount, so he wants to make greater than or equal to 250. X, you should define this, and I'll make sure you have a space on your test tomorrow. X is for the hours for a job, and Y is going to be hours for his internship. All right, and then my last piece of information is that he wants to work more than 15 hours a week. I'm sorry, does not want to work more than 15 hours a week. So that means X plus Y is not more than, so that's less than or equal to 15. All right, both of those things, those are the answers for part A. Part B says can the student work 5 hours at his job and 15 hours at his internship? To answer that, you either have to graph or plug in. And because they don't give you a graph, I'm going to show you how to plug in here. So by plug in, what I mean by that is 5 is your x value, 10 is your y value, and we're going to see if it makes the equation true. So if I do 25 times 5 plus 12 times y, I want to know if that is greater than or equal to 250. And I meant to say 10 here, not y. When I do that, I got 245 greater than or equal to 250. So is 245 greater than 250? No. So the answer is no, he cannot. That will not meet what he's trying to do.